Hey everybody, welcome back to ACE 427. This is week 3 and we're covering chapter 5, Prices over Space and Time. And this week's lab is going to help us understand the concept of financial full carry, how to calculate it, and what it means for markets. Alright, so let me get you oriented to what's going on in this spreadsheet to start with. At the top we've got these instructions, and the first big instruction is to just get these shaded cells filled in. So let's focus on that first and then we'll come back to the rest because we kind of got to get that all set up. So what do we have here? I've went out and put together a short series of monthly nearby futures prices and monthly first deferred futures prices, and those are a little bit of a pain to assemble, so I wanted to just do that for us, and so you're welcome. It's a little bit tedious, so I wanted to not spend too much time on that. So we'll talk about that a little more in a second. The third column here is the LIBOR interest rate, and that's expressed as a decimal. So many of you are probably wondering, what is the LIBOR interest rate? So let's take a look at that. I'm just going to navigate over to this site called Investopedia, and they've got a little article that explains what LIBOR is. It says that LIBOR stands for the Intercontinental Exchange London Interbank Offered Rate. And down here it says it serves as the primary indicator for the average rate at which banks that contribute to the determination of LIBOR may obtain short-term loans in the London interbank market. So it's a real interest rate and it's determined in the market and it's often used as a benchmark. So we're going to use it here to serve as the base of our interest rate in our calculation. You might recall this equation for financial full carry from chapter 5, and we're going to need to plug an interest rate into that. And if you remember from the text, it's commonly taken to be, just as a point of reference, to be LIBOR plus 200 basis points. So when we go to calculate this column, that's exactly what we'll do. First, let's talk about this column E for a second, the premium charge on shipping certificates per day. This is kind of the standard assumption for the premium charges on shipping certificates that serve as the deliverable instrument for grain futures contracts on the Chicago Mercantile Exchange. These financial instruments were discussed a little bit in chapter 4 when we went through the process of discussing how futures contracts are actually delivered upon. So in the CME rulebook, the maximum premium allowable to be charged for shipping certificates that are eligible to be delivered on the futures contract is this 0.165 cents per day. So we're just going to assume that all the way down, and that'll allow us to calculate kind of a benchmark financial full carry value that has it at its basis the LIBOR plus 200 basis points for the interest rate, and this 0.165 cents per day on the premium on shipping certificates that is a fee for storage, if you will. And then you'll recall this F was the nearby futures price, so we'll have that available for us too. And when we get all of these columns here figured out, then we'll be able to calculate this financial full carry. All right, so let's calculate the interest rate. We have to do LIBOR. I've got it here expressed as a decimal plus 200 basis points. And you're gonna have to translate this basis points into a decimal that looks like an interest rate. I'm gonna do a little practice calculation here. I know that 200 basis points is equivalent to 2%. So I need to take 200 divided by like 100 or 1,000 or 10,000, whatever the right number is to get me to 2%. And I have a hard time remembering off the top of my head. If you guess it's 1,000, oh, that's not 2%, that would be 20%. So I'm going to add another 0. And if I'm divide by 10,000, that gets me to 2%. So what that means is if I want to calculate this interest rate to be LIBOR plus 200 basis points and express it as a decimal, I'll just say equals LIBOR plus, and I won't use that practice cell up there, I'll just do it directly here. My 200 basis points divided by 10,000, and make sure I get the number of zeros correct. Okay. So you can eyeball it and see that this number is indeed 2% higher than that one. So we must have did it correctly. And I am going to push on my keyboard F4, and that puts the dollar signs in both the row and column spot. And that way when I double click here in the corner, it'll fill all the way down and keep this cell fixed on the basis points. Okay, so now we have the interest rate column calculated. That will serve as this spot in our financial full carry formula. Let's move on to the next columns G and H. So columns G and H is not so much of a calculation, but I wanted you guys to make sure you could work through where I went and got these nearby and first deferred contracts from. So I just want us to think through in each row which contract will be the nearby and which will be the first deferred. And I'm not so concerned about the year here because that should be a little bit self-explanatory. So we'll just type in here the month. The nearby contract on January 31st should be March, right? So March, first deferred would be May, and that's going to be true in the next column. But on March 31st, the March contract will have expired and May becomes the nearby. And then July is the first deferred. And that's true also on April 30th. But likewise, on May 31st, the May contract has expired, and July is now the first deferred, is now the nearby, and that makes September the first deferred. And July 31st, July has expired, September is nearby, and December is first deferred. Okay, it's true there. June, September. Now on September 30th, Dece has become the nearby, and March of the next year will be the first deferred. And this is going to be true on October 31st and November 30th. But on 12/31, we roll over to March. And that makes May of the next year the first deferred. So that's true here as well in January and February. But now May becomes the nearby and July becomes the first deferred. Okay, so now we've got that filled in, and we can calculate the next thing that we really need for the formula. So in the formula, we have this number of days until the next contract expires, and what that stands for is the number of days between the delivery period of the nearby contract and the delivery period of the first deferred contract. And the delivery period always starts on the first of the month and runs for the first 2 weeks. We know that the monthly contracts always expire on the 14th or whatever is the first business day prior to the 15th of the month. And so we're just going to ballpark it a little bit and not worry too much about weekends, because we're going to say the number of days between March and May. Well, March, April, May, that's going to be 2 months. Call that 60 days. And that's true for all of these pairs until we get to September and December. Because September, October, November, December, that's 3 months and should be 90 days. Likewise for December to March. So I'll fill down 90, then I'll go back to 60 when we're back to March and May, and all the way down until we get to September and December. Fill that down to here, and one more 60 to top it off. Okay, so now we can take a second and make sure, but I think we've got all the columns that we need to calculate the financial full carry. So we've got the number of days, we've got our interest rate, we've got a futures price for the nearby, and we've got the premium charged on shipping certificates. So let's do it. Equals number of days times parenthesis interest rate divided by 360. Now some of you are probably noticing we're just doing simple interest here, which may be a little bit too simplistic to an actual individual's financing costs. But in some other contexts, the CME uses exactly this formula when calculating what is financial full carry. So we're just going to go with that method as well. Times nearby futures price plus premium charged on shipping certificates per day. Close parenthesis, and we should have it. That looks about right. Financial full carry as 12.19 cents between the nearby and the first deferred. So you can see that this number varies, and since interest rates are not varying very much over this time, it's mostly being driven by changes in the financing costs, not through the interest rate, but through the price on the nearby. You do see there is quite a bit of price variation as you go down here from $6 to $8 back down to $6, and that's driving why this financial full carry varies so much from like 12 to 18 back to 12. Okay, so that's financial full carry, and our goal is to get over here to this column where we express the spread between the nearby and the first deferred as a percent of full carry, giving us kind of a measure of how much their incentive there is to store in the market. So here we're asked to just go ahead and calculate the spread, and I'm going to do the deferred minus the nearby in my calculation because we have this full carry expressed as a positive spread, not as a negative, so we'll keep this one positive as well. And that's going to be able to just fill straight down. And you can see right here by looking at the spread at a glance, you can see we go from a positive spread to a negative spread at several points in this price series. And you probably guessed I chose 2012 as a year because there's interesting things going on in this year that we had a significant drought. And you'll see that as we got into the summer months, the market was very much inverted, as much as 40 cents here. And then the next summer in 2013, the market was inverted strongly as well. So that's going to really give us some interesting things to interpret when we calculate this spread as a percent of full carry. And remember, it's telling us something about how plentiful stocks are as well. 2012, we had a big drought, and we had to ration prices through the summer, anticipating a short crop that fall. And then 2013 was also a lean year because we were trying to live on 2012 harvest. And by the end of the summer, we had pretty high prices and very steep inversions, begging people to not store. And then things kind of went back to normal after we had our harvest in 2013. So you can see that right in the spreads. And then to calculate percent of full carry, we'll just say, okay, I'm going to take the real spread, and divided by the financial full carry, multiply that times 100, so we'll have it in a percentage term. Actually, looks like we've got to leave it as a decimal and then make sure that your field is selected to percentage, and then that'll make it look nice. Okay, so if I fill it down, what happens? We can see before the drought of 2012, we were having a positive carry as much as 50% in January. And then we get into the summer when the drought was coming and we had a severe inversion. And here, this number of minus 200%, minus 250, minus 350, that is telling you if you are holding stocks, you are not very smart right now because the market is charging you a very steep penalty to hold those stocks. It's begging for every bushel to be brought to the market. There is some relief in that once we finally get the harvest in the fall of 2012. But by the time we get towards the end of that marketing year into the spring of 2013 and the summer of 2013, we are experiencing a very large inversion again because we were trying to ration the short crop from 2012 until we get another harvest in fall of 2013, and then these spreads go back to normal. We get back up to 50-60% of financial full carry. And that I just talked you through is essentially the idea of financial full carry and why it's useful, because when you compare the financial full carry, this benchmark of what would be the minimum required to compensate stockholders for storing their bushels, when you calculate the actual spread as a percent of that financial full carry, you get a real sense of what kind of signals to store the market is telling you. Okay, so we've done number one. We've got some interpretations. Now we're going to plot both the nearby series so that we have a sense of what's going on with price volatility. And then in a second plot, I want us to plot the percent of full carry series. So we're going to plot this series with dates on the x-axis and this series with dates on the x-axis. So let's do it. And I'm going to select this style chart. And before I adjust the size of that, let me just go ahead and get this chart created. Same style. I need to add my dates to the x-axis by selecting the series, right-clicking, and choosing Select Data. Select it, edit, and insert the date column. Oh, I didn't like that, and I think it's because I gave it the column header. Yeah, okay, fixed. All right, so let's take a look at these charts a little more carefully. I'm going to make them a little bit bigger so I can see what's going on. Pardon me, maybe not that big. Okay, so let's take a look at these two charts. This is 2012 through 2013 in the fall, and we see we've got very high prices, especially compared to the prices that are right now in 2017. In 2012, prices spiked up a lot due to the drought, and then only recovered to lower levels after we harvested the crop in the next year of 2013. Now you see, when we calculate the spread of the nearby and first deferred as a percent of full carry, you see some very significant negative percents of full carry. And these spikes down is when the market is saying, please do not hold stocks. Bring everything to the market right now. We are almost out of grain. that's essentially the signal. If you hold stocks, you will lose a lot of money right now. So let's think about the timing of that. This is during the summer of 2012, and this kind of came up as a surprise because stocks were a little bit tight going into this season, and then we had a drought, and so by the summer we realized, oh, we need to really start ramping up prices and rationing demand, and bringing everything that we do have onto the market. Then we get a little bit of relief in this measure as we harvested in 2012, but this effect becomes very, very strong in the late spring and summer of 2013, saying, okay, whatever bushels you have from the 2012 harvest, you need to bring them out now or you'll lose a lot of money. And then things kind of recover as we harvest the 2013 crop. So you can kind of get a sense of how this measure kind of gives you an at-a-glance view of what's going on with those slopes of the forward curves. We spend a lot of time interpreting what those slopes of the forward curves meant in terms of incentives to store, and this metric, spread as a percent of full financial carry, kind of boils it down to an easy to interpret chart. And 2012 and 2013 was a really fantastic year to illustrate what those signals mean. Okay, so let me make sure. Excuse me. We've done 1 and 2, and we've kind of discussed all of these things. So go ahead and write up your interpretation of that discussion and put them somewhere that's easy for the TA to find in your Excel chart, and just get that turned in. So thanks everybody. Have a good week.